evening, everyone. Good evening. Yes, amazing. I'd like to welcome everyone to the 2024 Dr. Bruce J. Nelson, Class of 74, Distinguished Speaker Series. My name is Xanda Schofield. I'm an assistant professor of computer science here at Harvey-Mudd College. And this year's Nelson Series is titled Learning in the Age of AI, an exploration of the complex relationship between human learning and machine learning in the world of education and beyond. In this series, 3 industry experts, Sal Khan, founder of Khan Academy, John Warner, author and columnist, and today Emily Bender, a leading linguistics professor, help us understand how people learn in the age of AI. Before I introduce our speaker, I'd like to acknowledge the generosity of the family of the late Bruce J. Nelson, class of 1974, for establishing this educational series to honor Bruce's memory. Bruce died unexpectedly in 1999, though not before having a tremendous impact on the many people whose lives he touched as an unconventional, eclectic, and irrepressible free spirit. He graduated from Harvey-Mudd as an independent program of studies major, and later earned his master's in computer science from Stanford and his PhD in computer science from Carnegie Mellon. At the time of his death, he was the chief science officer at Cisco Systems. We are honored and grateful to the Nelson family for the opportunity we have each fall to host exceptional speakers who are at the forefront of their respective fields. Now it is my pleasure to introduce you to tonight's speaker. Dr. Emily M. Bender is a professor of linguistics at the University of Washington in Seattle, where she has been a faculty member since 2003. She is also adjunct faculty in the Paul G. Allen School of Computer Science and Engineering and the Information School at the University of Washington. In 2022, she was elected a Fellow of the American Association for the Advancement of Science, and in 2023, she was included in Time's inaugural list of the 100 most influential people in artificial intelligence. She is currently president of the Association of Computational Linguistics, which I would say is perhaps, if not the, one of the central international professional organizations for people working at the intersection of computer science and natural language, which includes me. So, big, huge fan here. Dr. Bender's public scholarship is wide-ranging, including work on grammar, how to reason about data sets, and fundamentally understanding what computers actually understand about language. When I first met Emily, it was through her work in advocacy within our research community to better our teaching and reviewing practices around ethics in computational linguistics and natural language processing. In addition, her persistence in pushing back on a very English-centered orthodoxy in a lot of computational work has led to the coinage of something called the Bender rule, which is that we must always ask and answer, what language was this research actually done in? Usually, if it's not said, it's English. Her recent work has focused on helping broad audiences and policymakers understand the technology that is marketed as artificial intelligence and on cutting through the hype around AI. Because so much of the technology in question involves language processing, her perspective has been crucial in the ongoing conversation around this technology. As a linguist, she brings knowledge of how language works and an understanding of how people process and react to language. Thanks to Dr. Bender's ability to articulate these key points in a way that is accessible and impactful for non-specialist audiences, she's become a go-to voice for public science communication on the topic, appearing in the media on average over twice a week in the past year. She also brings her message directly to the public through her podcast, Mystery AI Hype Theater 3000, which is co-hosted with sociologist Dr. Alex Hanna. Our format for tonight's lecture will be a short presentation by Dr. Bender, followed by an interview and conversation led by Dr. Kyle Thompson, and we'll conclude with a Q&A session. Please join me in welcoming Professor Emily M. Bender.
Thank you, Xanda, for that very kind introduction, and thank you everyone for being here, and my appreciation also to the Nelson family. This sounds like a lovely series, and I'm honored to be a part of it. As promised, this is too close. As promised, a short presentation. Sorry, I need to, can you hear me still? That's better, okay. Don't try to get answers from a stochastic parrot is my title. This bit.ly link has the slides as a PDF file, and the reason I want you to have that is that there's links to other resources in the slides that you can then click on. The bit.ly link will be here, this first slide, the second slide, and then at the end. All right, I'm going to start with Chatbots 101. Historically, chatbots aren't new, right? This is a thing we've had for a while, but they were built around specific user intents. And the idea was that there was some range of expressions you might use to get the system to take you to an operator. I'm really struggling with this. Take you to a representative or set an alarm or something like that. And the idea was that you had mappings from a range of words you could say into specific appropriate actions. Pros of this approach are largely that what the system can do, its affordances, are fairly clear to users. When you approach the system, you know what you can do with it. You might try a few different things and figure out what's going on. On the other hand, if you want to extend this system to do more and more different things, that's time consuming, and the resulting systems are brittle. They can do what they can do and nothing else. People are asking these days, what if instead the computer could reply to any input with text that was engaging and on topic? And those are the chatbots we have now, like with ChatGPT. Notice it's just replying with text that's engaging and on topic, and it's not designed to do specific things anymore. These things tend to be built with something called a large language model. So here's Large Language Models 101 in one slide. If you want a 50-minute version of this slide, that's that first link for you there. But basically, what a language model is, and language models are old technology going back to the 1940s, all right? It is a way to model the distribution of spellings of parts of words in some collection of text. So when people say, what does ChatGPT know? All it knows is what words go with what other words. That's it, just the spellings and how they line up. For the large language models that we are inundated with now, though, this collection of text is enormous, trillions of words, and also undocumented in the sense of we don't actually know what's in it. The people who built it don't know what's in it because they're working at a scale where they just have to grab everything they can get their hands on. In contrast, languages, like English, are symbolic systems, which means they're pairings of form and meaning. When we are using language, we usually can't experience the form without the meaning because we interpret it so fast, but they are separate things. On the other hand, the only thing a large language model can learn is about form, sequences of letters and punctuation and what's likely to come next. So that's the distinction that I want you to hold on to, and like I said, longer version in that other talk. In this paper with Timnit Gebru and others that I wrote in 2020, published in 2021, we coined a phrase for that, stochastic parrot. This is from the paper. A language model is a system for haphazardly stitching together linguistic forms from its vast training data without any reference to meaning, a stochastic parrot. And that phrase stuck, partially thanks to Google firing my co-authors over this paper. So why is it that ChatGPT seems to understand? Right, so what the model is modeling is what words are likely to come next. The system design, that little chat box, is set up to output word sequences that are plausible continuations of the input and also likely to get high scores from human raters. It's a separate stage that they called reinforcement learning from human feedback to sort of push those probabilities in the direction that will get these high scores. The user interface that they've set up makes it look like a conversation. Right, so here's this chat, and it's turning plausible neck words into what looks like conversation, but it's not. The fourth crucial component here is the users. That's us. We are skilled language users, and we can't help but make sense of the text that we encounter. And so we are turning this sequence of words into a conversation, but it's all us. It's not the machine. And I have to point out that we do this reflexively. We can't turn it off, right? You can kind of turn it off if you say the same word over and over and over again until it starts losing its meaning. But in general, unless you're doing that, if you're encountering text in your language, you're understanding it. And you're understanding it by imagining a mind behind it and what that mind might be trying to do by picking those words. Problem is, there is no mind. It's only in our imagination. For more on this, another talk. Okay. So, as advertised in the title of this talk, I want to talk about chatbots as information access systems. There's a whole bunch of these. Google now forces us to look at these AI overviews, whether you want them or not. Microsoft long ago incorporated ChatGPT into Bing. OpenAI just announced ChatGPT Search, as if we didn't have enough of that. Just before ChatGPT, Meta gave something called Galactica, which was a language model trained on scientific text, and it was supposed to be for accessing the world's scientific knowledge. It wasn't. It was just paper mache of scientific papers. The San Francisco Chronicle had a news assistant that was a chat interface to their coverage of Kamala Harris's actions, throughout her political career. Again, making paper mache out of their news reporting. New York City last year, put together a chatbot where you could get information about regulations, and it told landlords that they could discriminate based on people needing housing assistance, for example. All right? Over and over and over again, people are putting these up as information access systems, but that's a terrible idea. All right? We have to keep in mind that when the output is correct, that is just by chance. You might as well be asking a magic 8 ball. All right? People think that RAG, retrieval augmented generation, is going to make it better, but as I was saying, paper mache of relevant documents, paper mache of good data is still paper mache. Nothing has understood your query. There's no representation of actual information in there aside from information about the distribution of word forms and text. Also, if you were going to say, okay, I'll just carefully check everything that comes out, that ends up being more time consuming than actually just using old-fashioned message in the first place. And people don't do it, right? If the answer feels right, people are going to go with it. And then finally, I'd like to point out that if you had a hypothetical chatbot search system that was correct 95% of the time, that would arguably be more dangerous than one that was only correct 50% of the time. Because people would tend to rely on it, and the 5% where it's wrong would be the more obscure things where you'd be less likely to know. Okay, let's take that to 100%. Let's say we could hypothetically, counterfactually create one of these that was always right. That would still be a bad information access technology. And that's because setting these things up so that you get the answer to your question cuts off your ability to do sense making, right? When you put a question into the world, maybe you're talking to a librarian, maybe you're talking to your professor, maybe you're using Google search or another search engine, you're often faced with the prospect of refining your question. That's an important part of the learning. Understanding how the different sources you might access speak to your question, how they speak to each other, and how they're each located within the information landscape. And each time you do that, you set yourself up better to understand what comes next. So here's an example. Let's say you put in the search query, how do you treat clubfoot, which is a congenital deformity that occurs in my family, which is why this is used as an example. And maybe you get a response from, or a link to the Mayo Clinic, which if you're me, that's a little bit surprising because you associate the Mayo Clinic with cancer, but okay. WebMD, that's a site where I believe things are reviewed by actual medical doctors, but it's a commercial outfit. Discussions and forums, okay. Any individual piece of information from these, not so useful, but the ability to connect to other people going through the same medical journey is priceless. And then what if you got a Pinterest board, all right? To be fair, to get that last one to come up, I had to add herbs and minus hospital to the query. But the point is you can have lots of different information sources, and if you see them in their original context, that is important and valuable information. But if instead you just got an answer that came out of a chatbot, you wouldn't know which of these it came from, and you wouldn't have had the chance to add to your information about, okay, what is WebMD good for? Oh, the Mayo Clinic doesn't just do cancer, and so on. So, we really need to be leveling up our information literacy practices, especially now. This chatbots as search paradigm encourages us to accept answers as given, especially given how they are stated with a sort of friendly authoritativeness that is the style of the chatbots. One of the things about leveling up our information access practices is holding high expectations regarding provenance. Where did that information come from? How did they know it? What was the methodology underlying it? And for more, here's 3 papers on that topic. Finally, because this is a series about AI, I had to put in a slide about AI hype. I want to point out that the very phrase artificial intelligence is a kind of hype. It's worthwhile keeping in mind that ChatGPT, AlphaFold, DALL-E, et cetera, aren't the same thing. That's not one system. But if we talk about them as if they were, it's harder to understand how each actually functions and what the limitations are. And also, the ersatz fluency of ChatGPT is especially misleading, trading as it does on your linguistic ability. So, for more, there's a link to the slides again. As Xanda mentioned, I have a podcast with Dr. Alex Hanna, and she and I have a book coming out in May. Please watch for it. It's called The AI Con, and we are very excited to share that with the world. And now I'm excited to do this interview and hear your questions.
Thank you all for coming. All these intelligent human beings here. Not a single stochastic parrot in the audience, I see. And thank you so much for that presentation. So I wanted to start off by thinking of how an audience member might take up this conversation. On the one hand, in the AI discussion, large language model discussion, we have some of the most wealthy, powerful, influential companies. We're talking about the Googles and the Microsofts, and they're saying GPT, LLMs, it's going to revolutionize the way we write and conduct business and do research. And then on the other hand, as a thoughtful and humble computational linguist, and you're saying that maybe there's some bluster that they're sending our way, and it's hype and hot air. So why should someone in the audience believe you over these big, powerful corporations?
Yeah, well, you came, right? So I have three answers to that question. The first one is I'm not selling anything, aside from a book, but still, was saying that before I wrote the book. The second one is it's actually not just me. There's a lot of people that I've been learning from and learning with through this process. And I encourage people to read the works of Meredith Broussard. She's got a couple lovely books. One is called Artificial Unintelligence. One is called More Than a Glitch. Ruha Benjamin, also beautiful books, Race After Technology, and especially Viral Justice, I really loved. Sophia Noble's Algorithms of Oppression is amazing. My co-author, Dr. Timik Giroux, my co-author and co-host, Dr. Alex Hanna. So there's a bunch of voices on this side. And then the last thing is to say, I think linguistics is actually a really key part of this conversation. As Xanda mentioned in her introduction, it's linguists who study how language works and how we do language. And how we do language is a big part of the magic trick that is ChatGPT.
Excellent. We were actually lucky enough to have Ruha Benjamin for our last year's Nelson series. And yeah, these different voices are really adding a lot to this conversation. I wanted to follow up, you frame this around information literacy. And I know this term gets used a lot. And someone might say, look, we had Google search. And then there's Wikipedia as a source of information that people might use. Now we have AI. Is this just this is just the next thing, and we just need to become information literate about this, and we'll be good to go? Or is there something more complicated going on with large language models?
I think there's a fundamental distinction here. Certainly, Google search is a different approach to information access, and it's got problems. And a lot of those problems, as Sophia Noble documents, has to do with the fact that that's actually an advertising company that has a search interface on it. And so it's not set up as information access as a public good. We have the practices of libraries and librarians, which are a great way of accessing information. You didn't go to the library and get an answer from a librarian. And even though we say, you can just Google that, we're not really going to Google and getting an answer. In both cases, we're getting directed to sources, and there's important differences in what kinds of sources tend to get surfaced and how accessible it is. But in those cases, we can go and look at those sources and locate them in the information landscape. And similarly with Wikipedia, you're not supposed to cite Wikipedia, but the thing about Wikipedia is that there's a strong culture of citing sources. And so you can go through Wikipedia and find sources and see how they relate to each other. With large language models, otherwise known as synthetic text extruding machines, you get a sequence of words that you interpret and make information out of, but you have no idea where they came from. And they didn't actually come from anybody. Nobody said that. And I think that's a big difference.
To follow up on that, I can imagine someone that's used GPT as a starting point for research or just to learn about a topic. They might go, sure, I can't be totally sure what source this came from. It's synthetic text, but the real thing going on is me plus GPT, and I'll evaluate what's working and what's not, what's good and right and true and what's not. And so it's that combination that can get me going on learning about a topic and conducting research. What do you think about that?
So I have lots of hesitations. I think part of it is as you're exposed to things that you take as information, as we will when we see text, it is hard to dislodge something if it turns out to be untrue later. And I think it's good information practice to keep track of where things are coming from, and nowhere is hard to pin. And then on top of that, I didn't talk about it, but there's huge externalities to these systems. They have massive environmental costs. They are built on data theft and labor exploitation. And so, I think you're better off doing it the old-fashioned way.
That actually connects to a conversation that we had earlier about some people might be aware of the environmental costs and maybe the labor costs as well. And first, actually, would you mind telling the audience a bit about those environmental costs in particular?
Yeah, so this is not my own research, but actually a really good source these days is the Tech Won't Save Us podcast by Paris Marx. He has a recent series on it. Also, Sasha Lucioni is a great researcher in this area, Emma Strubel. Turns out that things happening in the cloud sounds light and fluffy and clean and far away. Those are actually enormous data centers that have a lot of hardware in them, that run on a lot of electricity, and that require water for cooling, clean drinking water that then can't go back into the water supply. And we have news stories now of, for example, carbon-fired power plants that were supposed to be closed that are staying online to provide enough electricity for these data centers. And data centers aren't just for large language models or so-called AI, but they are increasing as companies start chasing after these AI dreams.
So earlier I had asked you, what if someone thinks, okay, I appreciate that there's this environmental cost, but the promise seems to be from certain thinkers and companies, if we use these technologies, that cost will be offset by the gains in, we'll find solutions for climate change or social problems. And so they might say it's worth pursuing the AI revolution.
Yeah, I think the answer I gave you before is, okay, let's fill up the entire province of Alberta with magic 8-balls and set up machines to shake them, and that'll give us solutions. Like it's magic, it's magical thinking. There's no reason to believe that synthetic text, if we just keep going, is going to somehow solve the climate crisis. That doesn't make sense.
Do students know what the magic 8-ball is? Is that still a toy you encounter? Maybe to push back on that a little, someone might go, okay, I get, right, that would not be a good scenario. But is say, asking GPT something, we do, there's human raters that have helped improve some of the connections it might be making in the network. And so its answers aren't so stochastic. What do you make of that?
So, I mean, it's true. Also, magic 8-balls can only give you answers to yes/no questions. So, yeah, there's a little bit more flexibility with ChatGPT. So the process with ChatGPT, first of all, not open, despite being OpenAI, right? But there's an enormous collection of text that was gathered. We know something about what's in it, but we don't know everything. And then this reinforcement learning from human feedback, where human raters give information about how good an answer was. We don't know whose humans were. We don't know what their training was. And there's no reason to believe that even if that gives slightly better answers to questions that we consider factual questions now, that it would lead to any new discoveries. Right? That's not what that process should lead to. And on top of that, behind all this, the solution to the climate crisis is not a technological fix, right? That's a political problem. And so if we're chasing after some AI that's going to come up with a tech fix, that's hopeless 3 times over.
What do you think are some applications of large language models or AI that might have some positive benefits? Do you see any, or are you a pretty hard skeptic all the way around?
So we have to define terms. Language models as old technology are important components of spell check, of automatic transcription, of machine translation. So there's a lot of uses of language models that make sense because they are choosing among possible strings that came out of some other process. Right? So we have an audio stream. Here's what those words might have been. Which one looks the most like the training text? That's a perfectly sensible use of a language model. We don't need something trained on trillions of words to do that, though. What I don't see any benefit for is synthetic text. I have one of the talks that I linked to, the title is actually ChatGPY, when, if ever, is synthetic text safe, desirable, and there was some third adjective, I don't remember, appropriate maybe. And the answer is basically never. And the one use case that someone gave me that seemed kind of compelling, if you could set aside all the environmental cost and all the social cost, is being able to search for something that you can't quite think of. What was that movie where the one actor, right? Yeah, ChatGPT can give you an answer to that. You can go check it on Google. Is that worth the environmental cost? I don't think so.
Speaking of language and the terms we use, you use synthetic text, and you sometimes refer to these AI systems as synthetic text extruding machines. And also you use provocative language like hype, that thing's full of paper mache. I'm going to use that, by the way. I think that's a nice way of saying something is full of BS. This might strike someone who's like, they've used GPT, maybe asked it a few questions, had fun with it right when it came out, and it just might seem like a big gap between these terms, provocative terms, and the experience that they're having. What do you think about how we refer to these systems?
Yeah, no, it's an interesting point. I think that language is really important, and the extruding in synthetic text extruding machines is deliberately a little bit gross. Like that's meant to be sort of evocative of something you don't want to touch. I think that there's a lot of commercial interest behind wrapping this up as shiny and exciting. And I think that one of the tools that people who don't have billions of dollars have to push back on against that is descriptive, evocative language. And so I'm going to go for it.
In the theme of like resistance, how do you use or don't use any of these large language model systems, GPT, the things that are on the market in your own life? And how do you see someone that's going to work for a company or performing research where they're really encouraged to use these tools, we can put that in scary quotes, like, how do you think of that?
Yeah, so I don't use them. I am constantly being sent synthetic text from people who, oh, look at this funny thing. I don't want to read it if nobody wrote it. I do Google searches still, and I have to like quickly skim past to get down to the actual links. If you are in a corporate setting where you're being encouraged to use this, or even in an academic setting and people around you are using it, I think it's worth asking some pointed questions, right? What are we automating here? What is the input? What's the output? What's happening in the middle? How did we evaluate that it actually works in our use case? What's happening to our data when we're using this? If it's a third-party system, is that okay? How is this conceptualization of what's going on datafying people, maybe? I think there's a lot of questions you can ask that don't come across as Luddism, although actually the Luddites were amazing. Please read Brian Merchant's great book about the Luddites. But they do come across as scientific and grounded, and I think that's a great place to stand.
I've also heard folks say maybe we would prefer students to not use GPT, et cetera, in their studies, but we need to prepare them for the world beyond graduation, and they might face these pressures and they might have to use these technologies. Should they be trained in some sense to at least understand how they work and how they might use them in some use cases?
Yeah, so I grabbed my phone here because I have this, it's actually an excerpt from my book that I wrote for my newsletter first about how I wish universities would respond. This is the statement that I want to see come out of some university about AI. So, we're going to prepare for this AI future that everyone is talking about by committing to fundamental research across disciplines, but especially the humanities and social sciences. Of course, we're concerned about the ethical and equitable development and use of the technology, and that's why we need scholars who are innovating at the edges of our understanding of how humans experience life, how power works in society, and how we can reshape our social and economic systems towards justice, equity, and sustainability. And we recommit to our mission of training students to be critical thinkers across disciplines, who can consider sources of information and locate them within their context, who can evaluate toolkits for the tasks they are taking on and decide which tools fit which task, and who can see through the glib marketing that power cloaks itself in.
Yeah. Let's do a special faculty meeting and put it up to a vote right now. No.
You could be the first.
So maybe we could bring this to a place like Harvey Mudd, where we have an honor code, and that's how we try to instill and encourage students to do their own work and to have integrity. That was at maybe an institutional level. How do you think, as a professor, how do you think about policies for a classroom and working with students that might feel a pressure to go to GPT when it's 2 in the morning and they haven't finished their assignment, and maybe they are feeling overwhelmed and stressed by school.
Yeah, no, I feel you. And I know that especially at an exciting place like Harvey Mudd, there's so much going on that it's very easy to end up as a student with too much to do just because there's so much to do here in the first place. And what I tell my students is, I don't like, for me, grading a paper is providing feedback on what they've thought through and helping them take it to the next level. There's no point in doing that if what they've handed me just came out of GPT. Right? That's not responding to anything they wrote, is not helpful. And so I ask them to please not do that. And I also think it's really important that we don't assign homework or essays just to keep the world's supply of student papers topped up. Right? Ask any faculty member drowning under papers they have to grade. Could there be fewer of these? Yes, there could be fewer of these. We would be happier. This is all about learning experiences. And so if you find yourself in a position where you can't put enough time into all the things you're trying to learn, please ask for help. Please ask for help solving that problem rather than trying to just patch it together with some extruded text, because that's not doing you any good and it's just a waste of everybody's time. That's how I put it.
On the idea of institutional policies and how an institution thinks of itself in the face of these kind of pressures to be innovative and adapt. And it can probably feel a bit scary for an institution to say, we're just going to not step into this AI moment and start to adapt and use this in our programming and encouraging students to use that. What would you recommend for people that have to think about that question at an institution at college?
I had the great privilege to speak at a meeting of the deans of the Pac-12 universities last year when that was still a thing. And we weren't flying across the country for sports, sorry. And I got to say to them, the reason this is your problem right now in this moment is not that there's been a huge technological breakthrough. We are not on the verge of AI companions and AI assistants that are going to help us do our work. All that's changed is we now have fluent synthetic text extruding machines and a lot of money behind them. And I'd like to see the academy not bowing to the sort of trends and fashions of venture capital, but actually staying true to our values. It's hard, but it's worth it.
Sometimes AI use is framed as an equity issue if someone, maybe they don't have access to the information literacy that would help them narrow down a search on Google, the way that you were talking about how you critically examine the different sources and you see which ones link up with the question you're asking. Is there any value in someone that won't have that training? Maybe I can picture someone in high school and they have GPT and it does provide some kind of in the ballpark answer and it's a one-stop shop.
So the problem is the way you get that training is by doing it over and over and over again. And so if we say we're going to solve equity by handing people these answer machines, then we're actually making the equity issues worse. Not to mention the fact that these systems have absorbed all kinds of biases, and that's getting spat back out. This talk didn't include my cabinet of horrors, all the collected examples that I have, but I'm sure you've all seen some of them. And so yeah, I think the equity issues are exacerbated rather than improved.
We'd also previously talked about when you're having a conversation with someone, at what point do you want to decide to intervene and reject the terminology they're kind of imposing on the conversation, right? You said, we need to define our terms. And I noted that sometimes someone will say, oh, I asked GPT a question, I got this compelling response. And I say, well, it actually can't answer because it doesn't understand things. And this makes me annoying sometimes. So how do you manage that kind of challenge?
Well, by being annoying sometimes. So the Bender rule story that Xanda shared, I didn't name that, but it got named that because I was at this conference going up to every poster and every talk that didn't say what language and saying, excuse me, what language was this on? Which is a ridiculous question, right? And embarrassing for both me and the person I'm asking. And so I'm glad to lend my name to it so other people can blame it on me. But yeah, there's a certain amount of being annoying. But also there's some choosing your battles, right? So if the person is just talking about their own habits, that is a lower, I'm sort of less incentivized versus someone who's making a proposal for what the institution should do or trying to convince somebody else. And there's the annoying and then there's the coming in with asking questions, which is slightly gentler, sometimes works, depending on my mood.
So it is probably the conversations you're having, right? It's a constant battle against, these tech companies have promoted a lot of AI hype, as you describe it. How do you stay motivated? How do you stay optimistic? I have your podcast that I get to listen to for catharsis on these issues where you challenge these ideas. How do you stay healthy?
Yeah, well, the podcast, honestly. So that it's very snarky and irreverent. And actually, that reminds me of a story. I've gotten to go to Washington, D.C. a couple of times to talk to policymakers, which is super exciting. So that's something that keeps me going when I have these impact moments. And I was talking to a senator's staffer who pulled out a bunch of my papers and asked me questions about them. And then he got around to asking me about what I thought about open source and was that going to be a solution? I said, honestly, I don't know. But the next episode of our podcast, we're going to have some experts on to talk about that. And he said, oh, great. And I said, just so you know, the podcast is snarky and irreverent. He says, oh, I know, I listened to it. That was so great. But the thing about the podcast that I didn't really appreciate was that it's actually built community. So every one of the episodes starts off life as a live Twitch stream, and we have people in the chat. And we hear over and over again that folks felt alone being the only one who didn't see things this way, who hadn't bought the hype, and being able to be in that podcast community really helped. And I think that is just one example of how important it is to build community, find your group chat that you can back channel with, and snark together about the terrible things that you heard, and also celebrate the wins, and that helps.
It makes it a lot of fun that there's like recurring snark too about an article feeling the need to start off by saying, we asked GPT, and then they drop that in there. What's maybe another, could be like a LLM myth or pet peeve that you would run into a lot, and maybe you have 3 minutes to talk with someone about this. Like, how do you go about debunking this idea?
I think one of the ideas is that retrieval augmented generation fixes everything. That, oh, well, we're just going to have it search the web, and then it's going to answer based on the things that it found on the web. And it's true that it's a slightly different system setup. It's true that it takes the query, turns it into a web search, and then runs some kind of a prompt that says, answer this query on the basis of these documents. That doesn't make it right, and that doesn't help with this fact that it's setting it up to just give you the answer rather than doing the more information-seeking, enriching behavior. And so I think that's one that comes up a lot. And also the idea that just making it bigger will solve these problems. It's a big pet peeve.
Say more about that when you say, like, someone, what would it mean for someone to make it bigger and think that this works better?
So yeah, larger model, deeper connections, more text. And I think what's happened is that we're dealing with data set sizes that are just too big to really understand what's in there. And so then people can easily imagine, oh, well, the computer has processed all of that. And so therefore it must be getting all the good information out of it. It's magical thinking, but I think because the scale is so big, it's easy to say, oh, that must be different because it's so big.
What about the idea that, yes, the arguments you're making now, the research you're doing now, it applies to LLMs as they currently are, but it feels like things in this AI space got better, the products got better at answering questions, and so there's this real strong sense that just give it time, this will surely be a different landscape in 10, 20 years, and shouldn't we be anticipating that future?
Are there any other areas of technology or science where we evaluate what's happening now based on an imagined future? This seems like AI somehow gets this pass of like you can cite the future, and therefore any limitations now are moot, and it's distressing.
What do you think it is about AI? Yeah, why does it get this pass in your mind? Like, what is it about the technology?
It might be the way it is so deeply connected to imagined futures in science fiction. And there was a great podcast they've finished now. It's called the Radical AI Podcast. That was like 2020 through 22 maybe. And they had a scholar on there, whose name I can't remember, but she made the point that when you're looking back at scientific progress, you can say, we built this, and then that meant that, and you can draw a straight line. And then people just sort of imagine into the future that it's the same path. We've just been running along this path and we're going to keep running, and it's only a question of how fast do we get there and who gets there first. But anyone who does science knows it doesn't work that way, right? Science is about spreading out and trying different things and talking to each other, and the destination is actually not known, not predetermined. And for some reason, the people who are working on AI, maybe because they do all of these like benchmark leaderboards, maybe just picture this path that's very straight and narrow, and then other people hear that from them, and it's sort of part of the zeitgeist about it.
This actually was a question that was asked in the previous speaker's talk, and I think it applies here. Is there a moment where you would be willing to say, now it really has reached, it's crossed some threshold, and we're getting at understanding, and the podcast is shutting down?
Oh, I hate to think about the podcast shutting down. We have so much fun. No, I think so. In the Octopus paper, Alexander Kohler and I define understanding as mapping from language to something outside of language. And so if you're talking about a virtual assistant that you can use to turn on and off the lights or set an alarm, that thing has understood. It's just that the range of things it can understand are small and predetermined. And so, do we want to build systems that have slightly broader ranges? Okay, well, let's do good engineering and spec out, and here I'm channeling Timnit Gebru from a talk she gave at SAT-ML in 23. She's an engineer by training, and she says the first thing you do in an engineering project, I'm sure many people in this room know this, is you set out the specs. What are we building, right? We can build well-scoped technology that involves natural language, and then we can say, look, if we did the thing we tried to do, I'm not interested in trying to build artificial life.
So I'm sure many of you have questions for Emily. So we're going to transition to a Q&A. I'll give you a question in the meantime, but we're going to put a QR code up on the screen, and you can submit your questions, and we'd love to hear from you. As they're doing that, what would you say to our seniors that are going to graduate and go into various STEM fields, maybe work for some of these Googles and Microsofts and others, and maybe do research, and they're going to have AI around them, people encouraging them to use this. Maybe it's even required in some domains. Like, what message do you have for them forward?
I think step one is be prepared to ask pointed questions. So these things from before, right? What are we automating? Why are we automating it? Is this really a good approach to that automation? How do we know how well it works? And then another thing, before you go out into the world, it's worth thinking ahead of time where your own personal red lines are. What is technology that you would be unwilling to participate in building? What is technology or other work that you would feel the need to actually become a whistleblower over? And I encourage students to think about this ahead of time, because I think it is easier to think that through when you're not in the moment, rather than sort of like, well, okay, I don't love this, but it's okay, and then one step more, and then finally the red line is behind you. There's a fantastic resource called the Tech Worker Handbook that you can find online, that's got stories of whistleblowers that, in your winter break, I was talking to someone about how you're going to have nothing to do when classes aren't in session. Maybe that'd be a time to go read the Tech Worker Handbook.
Thank you so much. Okay, we have some questions coming in. The first one from Stefan, and I think this really connects with the theme of this series. What are the major pitfalls of AI-assisted teaching?
So AI-assisted teaching could either be teachers using these systems to create lesson plans, or it could be you've got AI tutors in the classroom. And I think the pitfalls are, if you think about like students interacting with bots, as opposed to interacting with each other and with the instructor, is first of all a sort of a loss of community, loss of chances to connect, which I think now feel even more precious after the stay-at-home years of the pandemic, and loss of the chance to learn from each other, and also these issues of like, okay, but where does that information come from? And then same for teachers using it to set up lesson plans. Again, where did that come from? How when you create a lesson plan, it's because there's something that you want to impart. This thing that came out of the machine, is it based on someone else's lesson plan who's maybe got a different idea than I do, and so on? I think that there's lots of disconnection there too.
Excellent. This one, anonymous. Given the state of LLMs in the popular view, What do you think the critical path forward looks like to have responsible AI usage in society at large, if that even exists?
So it starts with defining terms. What do we mean by AI? And I think it would help to have things like requirements for transparency. We should always know when we're encountering synthetic media. We should know what the training data was for any automated system. And I would love, this is my like ultimate wish list item, could you imagine if OpenAI were liable for everything that came out of ChatGPT? That'd be fantastic.
Connecting with that, on the question of ethics, given the unspeakably disastrous effects that AI has on the environment, is there any form of ethical AI? Earlier in the day, we talked about maybe some more like local versions of LLMs. What do you think?
So again, AI doesn't mean anything, but you want to talk about machine learning, you want to talk about language modeling. These things don't have to be so big, right? They don't have to be driven in data centers. And sort of to the point of how do we get to a better situation, one thing might be transparency about environmental impact, right? What if every time you went to put in a query to ChatGPT or create an image through Midjourney or DALL-E, you just saw a little ticker saying this much more water used or something? Would that help people make different decisions? How would it change things? And you know, it would be really nice to know, like, this search engine uses this much electricity, and this thing that's spitting out, you know, a paragraph where each word has to be calculated based on the previous ones uses 30 times more. And if you could see that, that would be helpful. If we could somehow actually charge the companies for the externalities, that'd be even better.
So we've talked about resisting at a personal level and maybe within a workplace environment. What do you think about just general legal regulation of AI research, LLM research? Is that the right solution?
So the academic in me doesn't like the phrase regulation of research, I have to say. But I think that there is there's an interesting issue that's coming up with open source models. And so in particular, you've open source or open weight, where someone can download the model. It's not really open source, but like Llama from Meta, or Stable Diffusion, which is an image generation thing. And these are systems that can cause a lot of harm in the world through creating synthetic media that is misleading or otherwise harmful. And Stable Diffusion exists in many, many copies around the world now because people downloaded it. And so I think that there might need to be some kind of accountability for things you put out in the world, either as research projects or as products.
What about advice for people that have become interested in and become part of projects in large language models or machine learning? And I'll add a little bit to this, just it's really cool and nifty, and like there's a reason this topic keeps showing up and draws people in. What advice would you have for those folks?
Well, first of all, I don't want to tar all of machine learning with the same brush, right? There's machine learning is diverse. I don't like the term because learning sounds like something that it isn't, but applying statistical modeling to diverse kinds of data and diverse kinds of statistical models, that's definitely interesting. I think in general, it's like really pinned down, you know, what's your research question, and what's the why behind that research question? Why should somebody care? And sort of dig into any components that you're using that you didn't build. What are your assumptions about those components, and are they grounded? And I think that would be good paths forward for that kind of research.
Why do you think there is so much focus on language models in what gets bundled as AI, this clearly fraught term? So how do you feel about other areas of AI research outside of natural language processing?
So I'm a computational linguist, so I have less to say about where it doesn't have to do with language. I think that there's a lot of excitement around the AlphaFold project, right? It won Nobel Prizes this time out, I think. So this is a very carefully constructed data set of gene sequences and protein shape, so I got it right. I am way out of my expertise here. But the point is that the data set was built over like 50 years by biochemists doing this work. And then folks at DeepMind, which is now part of Google, applied machine learning to be able to take new sequences and come up with the folded proteins, and it works very, very well in the sort of high frequency, most common types of proteins, apparently. This is what I hear from the people who know more about this than I do. That might be interesting. It might help sort of focus effort on those corner cases instead of the high frequency ones, perhaps. Like I think that there's usage for that. I wouldn't call it AI, even though the people who built it called it AI. But yeah, I think there's maybe outside of language and image, a little bit less scope for this overhype because it is less immediate to us. It's less sort of connected to our immediate experience.
Excellent. Maybe going one layer more zoomed out, I think there's a lot of talk of there being some kind of LLM or AI arms race, as Tom asks in this question. We might be able to regulate as much as we want in the US, but how do you propose that we can prevent competing world powers from using this to destabilize our government through misinformation and less regulation?
Yeah. So one of the really concerning things about large language models is that all the companies making them have not done the first thing to like watermark the text. And so we can't easily clean it up out of our information ecosystem. And so even if we got folks in the US jurisdiction, for example, to put those watermarks, that wouldn't stop someone else from flooding our information ecosystem with synthetic text. I think that the answer there isn't, okay, well, let's just have more pollution in the information ecosystem, right? Just because we had the Deepwater Horizon oil spill in the Gulf of Mexico didn't mean that the Exxon Valdez wasn't also a problem. I think I got those in the wrong order, but you know what I mean. So, you know, it is worth doing good regulation, even if not everybody's going to follow it. And then thinking about what do we need to do to shore up our democracy and our systems of communication against misinformation threats from the outside. And boy, it does not start with newspapers setting up their own chatbots.
Okay, this is a longer one, so bear with me. We're going to get through it. It's like a paragraph here. Here we go. You mentioned that Google is, quote, an advertising company with a search engine. And clearly there's a lot of false information that you can find on the internet. Despite this, those who didn't embrace search engines and the internet got left behind in research and educational context. If everybody is using LLMs to help them do things like learn and code, and doing it helps them do it more effectively and efficiently than simply the internet, how do we not get left behind in our research and learning by rejecting LLMs ourselves?
Yeah, that's a good question. I think the first thing I would look at is the metaphor left behind. Who's going where, and do you really want to follow? I know that for one of the things that's in the large language models training data apparently is lots and lots of text paired with code. So it works as sort of a machine translation system. And that can help you code a particular project faster. We'd have to talk to the computing education folks to get the state of the art on whether it actually helps you learn to code faster. I'm not convinced, but again, not my specialty area. And I think also if what you want is a system to do good autocomplete in your coding, look for a system that's designed specifically for that, rather than someone taking one of these everything machines and sort of saying, yeah, it kind of works for this as well.
Excellent. Language is so integral to so many of human practices. And this, Jennifer brings up this question. If you could speak to the possibility of AI chatbots as being part of therapy or in psychology as a cure for loneliness, even if you think that there's nothing understanding on the other side, is there a potential application?
Yeah, there's all kinds of sad stories there. I think I know of 2 specific cases where people have died by suicide after interacting with a chatbot for a long time. There was a bunch of people who formed attachments with a particular, I think it was replica, and then the underlying system changed and they felt like they had lost that connection. I repeatedly see people proposing chatbots for psychotherapy, which is really frightening to me. one little Twitter victory that I had was somebody had taken a chatbot with a text-to-speech system attached to it, and then like set it up as if it were a psychotherapy agent, and like was advertising it as such. And so I went and looked. Turns out the company was based in Texas. So I went and looked up the part of the Texas regulatory state that regulates psychotherapy in particular, and just replied to his tweet saying, oh, well, you know, here's the people who regulate this, and bam, it was gone. So that felt good. Not saying the company was gone, but at least the tweet was gone. But my concern is that psychotherapy is one of the many, many places where at one level it looks like we're just exchanging text, we're just exchanging words. That's not what's actually happening in a therapeutic conversation. And you know, I get that people can be lonely, and we've experienced a lot of extra loneliness in the wake of COVID. And I think that just having a way to express yourself can help. And you know, there's a great technology for that. It's called journaling.
I think this relates a lot to conversations that I have with students and other folks about, it just seems wrong to just outright want to refuse this technology or to ban it or to not incorporate it in some way. So someone labeled themselves ChatJHB. I know who that is. Asked this question. I agree that using LLMs for answers is not a good application, but what about using LLMs for synthesizing and sparking curiosity about data? Almost kind of like that tip of your tongue feature that you said it might be useful for. Do you believe that LLMs are truly unique in a useful way, perhaps as part of a larger product or tool?
So as sort of a like idea generation machine, got to have a really interesting conversation with Ted Chiang in Seattle last November. And I think he was the one who brought up there was somebody who used the I Ching as they were writing science fiction. I'm not a literary scholar, so I don't know, didn't hold on to who the author is. And so there's like this kind of randomization that helped. And Ted was saying, so what's the difference between that and using a large language model? And I think the difference is that what comes out is fully formed. And so it is harder to like say, okay, here's the moment of randomization. I think the use of it to synthesize is very misleading because you'll end up with something shorter that probably includes some of the things that came from the input text. It might include some things that weren't there, and it's certainly going to be missing a lot of what was in there. And that is very, very hard to check for. If you're using it to get a summary or get a synthesis, how do you then go back and find what it missed? So I am not bullish on this. Again, still setting aside the economic and labor costs and the environmental costs.
Could I get Ted Chiang's phone number later? Great sci-fi author, if you know. Maybe to close out, if you're right about this being so much hype, and these tools are not going to revolutionize the way we do business or do medical research or anything, will there be a moment where companies will feel this and it's no longer like changing their business model to produce more profit, and they'll be the ones to kind of end the AI revolution? Do you anticipate that happening, or is there just so much in the hype business we're going to see this going on and on?
So very selfishly, a couple months ago, I was worrying that it looked like the hype bubble was deflating. You had like Sequoia Capital, which was one of the big VC firms, saying, we've put many more billions into this than we've actually gotten out of it so far. The rest of this money has to come from somewhere, right? And the reason I say selfishly is that I would like the hypes to still be going on in May when my book comes out. But we've actually written the book to be sort of more general, like how do you identify hype so that the next time, because this is not the first time we've been here, it's just the first time we've been here with this particular kind of AI. I do think that eventually the fact that nobody's actually there's no value here. Nobody aside from NVIDIA is really making money on it right now. I think that that's going to have to come home to roost. But the problem is that the people who are most excited about it have lots of money to keep pumping in. And so I think it's going to take a while.
All right. And what is the name of your book? Because I think we're all excited to check that out when it comes out.
It's called The AI Con. And the subtitle is How to Fight Big Tech's Hype and Build the Future We Want. Comes out May 13th.
Awesome. Well, thank you so much, Emily. That was fantastic. Thank you all. This is the last of the Nelson series for this year, and we're so excited that you came to join us in these conversations. We hope that you keep talking about this with friends and family and beyond. Have a wonderful rest of your evening. Thank you.